Okay, so continuing our discussions, we have here the source free RL circuit. So kanina, ang diniscuss natin is the source free RC circuit. So the same pa rin dito, no? For the source free RL circuit, we have to derive that using this series connection of R and L kanina, no? Ang ginawa natin doon is ang ginamit natin na circuit in finding the equation for free RC circuit is um, free RC circuit is this one, no? Ito, okay? So a series connection or I mean the parallel connection of RC. So dito naman sa source free RL, we have here the parallel connection of um, RL. Okay, RL circuit. Okay, so throughout this analyzing this circuit, we can probably have this final equation of free RL circuit. Okay, so kung mapapansin natin, no, parehas lang siya doon sa RC circuit natin, no? So sa RC circuit natin, ang pinagkaiba nga lang is that doon is V. Ang function ng time natin is yung voltage natin across the capacitor. Dito, ang function ng time natin is the current across the inductor. Okay? So, yun. And magkaiba rin sila ng tau. Okay? Or time constant. Doon is, ang time constant natin doon is RC. Dito, ang time constant natin dito is L over R. Okay? So, pero, disregarding their formation of equation, um, all of them all of them are following this graph, okay, graph of natural response. Okay, so they are all following that one. So ibig sabihin, no, we can also analyze we can also used to analyze the problem that is being involved in free RL circuit, same as what we have done in analyzing the source free RC circuit. Okay, so we have here a problem, no, examples. We have assuming that I of 0 is equal to 10 amperes. Ibig sabihin nun, the current across the inductor here at time t is equals to 0 is equals to 10 ampere. Calculate daw natin yung value ng I of t, no? Or current across current across the inductor at as a function of time, and Ix of t, which is the current across this 2 ohm resistor as a function of time. Okay, so there are two ways we can solve this problem. One way is to obtain the equivalent resistance at the inductor terminal, and the other way is to start from scratch by using Kirchhoff's voltage law. Whichever approach is taken, it is always better to first obtain inductor current. So there we have a two way of how to calculate the value of I of t here and Ix of t here, no? So we can use simplifying this circuit equivalent here, okay? Or we can just use KVL method, okay? So we have here the method 1. So ibig sabihin, we replace this circuit here into its equivalent resistance. Then eventually we can now find the value of I of t. So the equivalent resistance the same as Thevenin resistance at the inductor terminals because of the dependent source. So we insert a voltage source of V sub O is equals to 1 volt at the inductor terminals AB, as we could also insert a 1 ampere current source at the terminals. So applying KVL to the two loops result in these equations. Okay, so since meron tayong independent source here, okay, so we have to apply a 1 volt source here in order to find the value of equivalent resistance here. Okay, and at the same time, the Thevenin equivalent voltage. Okay, so at the terminal. So after that, no, we have here an equation. We perform here a KVL method, I1 and I2. Okay, so we generate this equation here. Okay, then we now have this I1 is equals to negative 3 ampere and I sub O, which is equals to negative I1, no? Kasi nga I1 tayo dito, so opposite sila ng I sub O. So that's why I sub O is equals to negative I1 is equals to 3 ampere. Then after that, finding the value of tau, no? So ito yung I sub O dito is yan na yung ating current across the inductor, no, if you can see here. So tau is equals to L over R equivalent. So meron na tayong time constant, then using the equation of free RL circuit, then substitute the value of tau or time constants, we can know this equation of I of t. Okay, then so method 2 is just by using KVL method. But take note that when we using KVL method here, okay, KVL method here, all of this equation here, or all of these parameters here as a function is a function of time, or function of time, I mean. Okay, so it's a little bit complicated when we using KVL method. Okay, but if you study this approach, it is very compatible with this problem. Okay, so I think me as I have to solve this problem, no, my preferable method is to using this one, no, kasi nga dito gagamit pa tayo ng ano yun, Thevenin method. Okay, so dito is diretso na tayong KVL, but yun nga, as I have said, it is these are all function of a time, no, so as you can see here, as a function of time. Okay, so so we have also a practice problem here, no, so please answer this one. Okay, so we have another example here. We have example number 3. So the switch in the circuit of has the switch in the circuit here, itong switch na to, itong switch na to daw is have been closed for a long time. So ibig sabihin, it is closed for a long time. Okay? So at t is equals to 0, the switch is open. So calculate I of t for t that is greater than 0. Okay? So we have here, so sabi dito, this is originally closed. So ibig sabihin, yung inductor natin is absorbing an energy, no? And until it come to a steady situation. Okay? So, then at t is greater than 0, gi-open natin to siya. So, ibig sabihin, itong part na to rito is na-isolate na siya. So, hindi na siya, it is no longer connected to this circuit. So, ibig sabihin, when we disconnect this one, this inductor here, okay, this inductor here will supply some energy to this part of circuit here, no resistances. Okay, by following this kind of graph here, no, yung natural response natin. Okay? So ito, okay? So ito. So yun daw yung situation. So the question here is, saan na ba yun? The question here is uh, calculate I of t for t is greater than 0. So we have to calculate I of t here, okay, for t is greater than 0. So when t is greater, or when t is I mean when t is less than 0, no, nung hindi pa daw nag-start yung circuit natin na mag-function, this is connected, no, so or close itong switch natin, and the inductor acts as a short circuit to DC to DC. So ibig sabihin, ito siya, we can find that this inductor here is short circuited, no, so ibig sabihin, it already have its maximum value of storing energy, no, so naka short circuited siya. Okay, so the 16 ohm resistor is short circuited. The resulting circuit is shown in figure 7.17, 7.17, and to get I1 here, we combine 4 ohm and 12 ohm resistor in parallel. Okay, so we have here, so ibig sabihin kung short circuited to siya, ito siya is also being short circuited, no, so take note that when you parallelize the uh, resistor that is being connected in parallel with this short circuit wire, no, so this resistor here will be have like a short circuited dead. Okay, so ibig sabihin kung ano yung configuration nito, ganun din dito. Okay, kasi nga parallel. Okay, so ibig sabihin mag-zero yung resistance natin dito. So ibig sabihin nun, itong lahat na to, itong dalawang branch na to is already short circuited. Okay, so to get I1, okay, we combine 4 ohm, 4 ohm, and 4 ohm and 12 ohm. Ito siya, 4 ohm and 12 ohm. Kasi nga short circuited to siya, so in parallel, kung short circuit dito siya, so itong 4 ohm natin at saka yung 12 ohm natin is now connected in parallel. Okay? So we have here the calculations. Ibig sabihin, it is equals to 3 ohm. So ibig sabihin 4 ohm and 12 ohm natin are equal to 3 ohm. So ibig sabihin yung I1 natin is equals to 40 volt divided by 2 plus the combination of 4 ohm and the 12 ohm. So we have here 8 ampere. Okay? So therefore, I of t natin is equals to 12 over 12 plus 4. So current division, no? 12 ampere over 12 plus 4. So ibig sabihin kung ano yung current natin dito, yun yung current na dumadaan dito kay inductor natin. Okay? Which is the maximum. So we have here 6 ampere. So ibig sabihin, at all times, which is t is less than 0, it means that this is connected. The current here sa inductor na to is equal to 6 ampere. So yung 6 ampere na yan is yan yung gagamitin natin when when this uh, connection here is disconnected. Okay? So we have R equivalent is 12 plus 4 over, so ibig sabihin when this is disconnected, so the remaining circuit now is ito lang. Okay? So we have series connection of 4 and 12. So we have here, ito yan siya. Then in parallel with the 16 ohm, so ito yan siya. So the result is 8 ohm. Okay? Then finding the time constants, we have time constants is L over R equivalent. So that is equals to 2 over 8 or it is equals to 1 over 4. Okay? So meron na tayong time constant. Now, using the equation for free RL circuit, so ito yan siya. Ito yan siya. So substitute the value of time constant. Then, nakuha na natin yung I of t natin. Okay? And yung I sub O natin is 2 yun siya. Okay? So, so we have also here a practice problem. So, please find way on how to solve that one. Okay? So, we have also another example here. So, please also solve that one. So, I think this conclude all of our week 7 lecture. So, I think next week will be the week 8. Okay, so please study this free RL and free RSC circuit. So this is very important in dealing with the circuit that we have to encounter in our previous major subject. Okay, so if you have any question, clarification, no, so yung hindi niyo naintindihan, please, 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 please ask it to me. So wag kayong mahiya. Okay? So kahit anong question niyo siya, or you can maybe go to my office, okay? No? Kung nahihiya kayong message, so you can even go to my office to ask that one. So that's why we can discuss it further. Okay? So please study carefully kasi nga, no, as I have said, mahirap yung majors natin. Okay? So actually ito lang yung mahirap, itong majors na to. Then pagdating nyo sa ibang majors, hindi ganun mahirap. As long as maintindihan natin tong concept ng EE211 natin, okay? All in all, um, the other major subject is uh, very not totally easy, but can handled, okay, carefully, if you have this topic. Okay, so I think that's all. Assalamu alaikum warahmatullahi ta'ala barakatuh.